Alright, this video is going to be on how to work with quadratics that are in intercept form. So intercept form looks like y equals a times x minus p times x minus q. So if you look at this, we haven't had p and q before in our equation, so those are new. Those are not like transformations that we've seen. However, this a here in the front still tells you what you're used to a telling you, and that means that it can tell us if the graph is reflected over the x-axis. It can tell you if there's a stretch, and it can tell you if there's a compression. So that's going to be the same as what we've seen before. The p's and the q's, if you can see, this is actually factored form, and so that means that when we solve these factors that we're actually finding the x-intercepts. So p and q are actually our x-intercepts, and that's why we call this intercept form, because it gives you your x-intercepts. So when we sketch a picture of the graph, we're going to go ahead and draw a little quadratic here and label some things. So here's my two x-intercepts. Since my formula has negative and negative, I'm going to say that those are both positive because you do the opposite sign to get it outside of that parenthesis. So that's our x-intercepts are p and q. And then right here down the middle, we haven't talked about it in this class yet, but you might have referenced it, hopefully you did, in your last math class. And so this line in between that you could fold the parabola in half over is called the axis of symmetry. So we know that these are perfect U-shapes. They're not lopsided U's, they're symmetric on either side. So if I want to find the equation of the axis of symmetry, that's going to be an x equals equation because it's a vertical line. And so the x equals equation is going to be the middle of p and q, right down the middle. So we're going to say that to find that number, we're going to do p plus q divided by 2. This point right here, as you know, is the vertex. And the x-coordinate of the vertex is going to be the exact same as the x value for that axis of symmetry. So the x value of our coordinate is going to be halfway between the p and the q, those two x-intercepts. So that's how we find the x-coordinate of the vertex. To find the y-coordinate of the vertex, you plug x in the equation to get y. So that's how we find the vertex. So when we are graphing these, we don't have to use the chart like we did from vertex form. We can actually take the x-intercepts and plot those points. We can find the axis of symmetry and plot that point, or draw that line, sorry. We can find the vertex and plot that point. And then if we're able to find maybe the y-intercept over here, then we know that it's going to be the same point reflected across the axis of symmetry, and we can draw that point over there. So it's going to be pretty easy for us to find enough information to graph these lines, even though we're not going to be able to use our normal method of using a chart. So we're going to go ahead and do an example of this so you guys can see exactly how it works. So the instructions are going to say to sketch the graph for y equals 2 times x minus 1 times x plus 4. So first thing, we're going to go ahead and look for the x-intercepts and the y-intercept. So the x-intercepts here are just going to be the opposite sign of each of these. So this x-intercept is positive 1. This x-intercept is negative 4. To find the y-intercept, we're going to go ahead and just plug 0 in for x. So my y-intercept is going to be 2 times 0 minus 1 times 0 plus 4. And that gives me 2 times -1 times +4, which is -8. So our y-intercept is 0, -8. So those are 2 points that we can graph. We also want to find our vertex. And so to do that, we're going to take these 2 x-intercepts and divide them by 2. So I've got 1 plus -4 divided by 2. And that gives me -3 over 2, which is the same as -1.5. And then for me to find the y-coordinate of my vertex, I'm going to go ahead and put y equals right there so I don't forget what I did. All right, y equals 2 times -1.5 minus 1 times -1.5 plus 4. And so what I'm multiplying here is I have 2 times -2.5 times +2.5. And if I multiply those out, I find that I get -12.5. So there's my vertex. My axis of symmetry, I don't feel like writing out all the words, so I'm going to say axis of symmetry is x equals -1.5. That's going to be helpful. And at this point, we have enough information that we can draw a pretty accurate graph of this. So if you have graph paper, you can go ahead and use graph paper. If you don't, just draw a sketch on your notes. All right, so if I look at my information here, I've got the point 1, 0. I've got the point -4, 0. I have the point 0, -8. There's that. I have my axis of symmetry at -1.5. So I'm going to go ahead and draw this all the way down. There's my axis of symmetry. The vertex is at left 1.5 down 12.5. There's the vertex. All right. And then like I said before, we know that this is the axis of symmetry. So if I want to graph another point, I can take this point and I can look how far away it is from the axis of symmetry, and then I can draw it on the other side. Now my y-intercept on this one was pretty convenient. It was easy enough to draw because it was right in there. Let's say your y-intercept was super far away and you needed to come up with some other points that you could draw. So here's my vertex. Typically I kind of like to go over 1, so 0 would have been a good number to plug in. 1 would have been a good number to plug in. You want points that are kind of close to your vertex. They're a little bit easier to draw. So let's say maybe I can type in -1. I could plug in -1 and see what the points are going to be for that. So I'm going to say here's how we find some other points. We want to pick some that are close to the vertex. And so I'm going to pick the point -1. And then for me to find the y-coordinate of that point, I just need to plug it into the equation. So I have 2 times -1 minus 1 times -1 plus 4. So that is 2 times -2 times 3. So that's -4 times 3 is -12. So another point here is -1, -12. So there's a point right there. And then we can put it the same thing on the other side of the vertex because we know that's symmetric. So there's lots of points you can find in there, especially if your y-intercept were so big or so small that it was hard to graph it. Like if you have a y-intercept of -72, you're probably going to want to look for some other points to be able to graph it. Okay, there's that. We also have been doing other things with our graphs. We've been finding characteristics for them. And what I mean by characteristics is like domain and range and increasing and decreasing and max and min. So that's the other thing we want to be able to do from the intercept form as well, is find all of the characteristics. So I'm just going to go ahead and make a list of some of the characteristics that we can find. Transformations are one that you can typically look for, but we're not going to get many transformations from this form, so I'm going to kind of ignore it in this situation. I'm going to look for the vertex. We can start doing axis of symmetry now that we've talked about it. I know that I'm going to look for x-intercepts and y-intercept. And I'm going to look for domain and range, increasing and decreasing intervals, and then max and min. So we got kind of a list of things to do here. I think that's everything. All right, so I'm going to start with my x-intercept because those are the easiest to find from intercept form. So my x-intercepts are +5 and -7. For my y-intercept, I just have to plug in 0. So 0 minus 5, 0 plus 7. So that gives me negative of -5 times 7. So that's 35. I know that to find my vertex and my axis of symmetry, for me to find that x value, I have to take the two x-intercepts and add them together and divide by 2 to find the middle. So 5 plus -7 is -2 over 2, so that gives me -1. And then for me to find the y-coordinate of my vertex, I'm going to plug in that -1. So -1 minus 5, -1 plus 7. So that gives me negative times -6 times +6, and that gives me +36. I'm going to go ahead and use this to draw a little sketch of the picture because that sketch typically helps me to draw stuff to find out my increasing and decreasing. It also helps me find my domain and range. So I've got a vertex at -136, so pretty high up there. And then I have x-intercepts. I've got a -7 over here and a +5 over here. That is not drawn to scale, but you can imagine kind of what it looks like. So for my domain, I'm thinking about what are the x values that I'm allowed to plug in. There's no x value that needs to be limited by subtracting 5 from it, or that should be limited because you added 7. There's no reason to limit x's that can be multiplied together. So I know that my domain is -infinity to +infinity, or you could say all real numbers, depending on which form you like to have your answer in. For my range, I can see that I have all the negative y values down here, and then I have a lot of positive y values up here, and the very highest y value is up here at the vertex at 36. So my range goes from -infinity all the way up to +36. Or another way to say that is my range is that the y value has to be less than or equal to 36 for it to work for this. So now I can go ahead and label for increasing and decreasing. Here's my little stick figure. He's increasing on this side. He's decreasing on this side. The x value at a left arrow is -infinity. The x value at a right arrow is +infinity. And the x value right here where he switched directions is -1. So I'm going to say he was increasing from -infinity to -1, and he was decreasing from -1 to +infinity. If you look at this picture, you can see that there is a max, but there is no min. I don't have a point down here that's the lowest point, so I'm going to say none for min. And the maximum is also the vertex, and so the maximum is -136.